Inside a standard residential cable, you usually have three main conductors: hot, neutral, and ground. Once you understand what each one does, basic wiring starts to make a lot more sense. The black conductor is usually the hot wire. It brings power to the load. The white conductor is neutral, which is the normal return path for current. And the bare copper conductor is ground, the protective conductor. Ground is there mainly for safety, not for normal operation. This slide shows the normal current path. Current leaves the source, passes through the load, in this case a lamp, and returns on the neutral conductor. So neutral is not just some extra wire. It is part of the working circuit during normal operation. If the neutral opens, the circuit usually stops working, even if the hot conductor is still present. The hot conductor supplies the load. It brings voltage to the device. That is why hot is considered the energized conductor, and it is the one most directly associated with shock hazard when a circuit is live. In a normal circuit, hot and neutral work together. One brings power to the load, and the other carries current back. Ground is the protective conductor. Under normal operation, it should not carry working current. Its job is to provide a safer path for fault current if the hot conductor accidentally energizes a metal case or another conductive part. That is why ground is not the same as neutral. They do different jobs. On a standard US receptacle, hot connects to the brass screw side. Neutral connects to the silver screw side. Ground connects to the green screw. This is one of the most important visual basics to recognize right away. Brass means hot, silver means neutral, and green means ground. The easiest way to remember it is this: hot brings power, neutral returns normal current, and ground is the protective path for fault conditions. If you keep those three roles in mind, simple diagrams become much easier to read. Now here is a fault example. If the hot conductor energizes the metal case of an appliance, fault current can return to the panel through the grounding path. That high fault current helps the breaker trip quickly, and that is one of the main protective functions of ground. The goal is to clear the fault fast, before the metal case stays dangerously energized. So this is the basic logic of the three conductors inside a residential cable. In the next lesson, we will break down what markings like NMB 14 halves mean and how to read cable labels correctly. Thanks for watching. See you in the next lesson.